Hello students, how are you all? I hope you are fine. So today's topic is laws of chemical combination from plus 1 chemistry, chapter some basic concepts of chemistry. So what are these laws of chemical combination? In the 17th century, scientists made certain generalizations during their quantitative studies of chemical changes that how atoms combine to form molecules. These generalizations are known as laws of chemical combination. So today in this topic we will going to discuss 5 important laws of chemical combination. These are: first is law of conservation of mass, second is law of constant composition or definite proportions, third is law of multiple proportions, fourth is law of reciprocal proportions, and fifth is Gay-Lussac's law of combining volumes. Let's illustrate the law of conservation of mass by doing an activity. Take a spoonful of sodium bicarbonate in a glass container. Pour a small quantity of water. And mix it to make a clear solution. Pour some extra water if needed. Now take a small quantity of vinegar, that is acetic acid, in an improvised container. Small plastic cap is used. Then place it carefully in the glass container so that the two solutions should not mix with each other. This we can do with the help of a thread. Now close the glass jar and tighten it carefully. Then weigh the setup and note down the reading on the weighing machine. Now mix the two solutions by tilting the glass jar and observe it carefully. You can easily notice the effervescence, which is due to the evolution of carbon dioxide in the reaction between acetic acid and sodium bicarbonate. Now weigh the setup again after the chemical reaction. The weight is almost same as before. This shows the law of conservation of mass. So let's discuss our first law, that is law of conservation of mass. It was given by French chemist Antoine Lavoisier in 1789. It states that during any physical or chemical change, the total mass of products is equal to the total mass of the reactants. In other words, matter can neither be created nor destroyed during any physical or chemical change. For example, in the formation of carbon dioxide from carbon and oxygen, here the gram atomic weight of carbon is 12 gram and the molecular weight of oxygen is 32 gram. So the total weight of reactants is 44 gram. So when carbon and oxygen combine to form carbon dioxide molecule, the gram molecular weight of carbon dioxide comes out to be 44 gram. So here the mass of reactants and products are equal. But in a number of reactions, especially nuclear reactions, the mass of products is found to be less than that of reactants. The answer is given by Einstein mass energy relationship. That is capital E is equal to mc square, where m is the mass lost and c is the velocity of light. So here, in case of nuclear reactions, some of the mass is converted into energy. That is why the mass of products is found to be less than that of reactants. Thus, the law of conservation of mass is modified to law of conservation of mass and energy, which states that the mass and energy are interconvertible, but the total sum of the mass and energy during any physical and chemical change remains constant. Let's further understand this law by doing a numerical problem. What mass of silver nitrate will react with 5.85 gram of sodium chloride to produce 14.35 gram of silver chloride and 8.5 gram of sodium nitrate if the law of conservation of mass is true? So, in this statement, the reaction given is silver nitrate combines with sodium chloride and changes into silver chloride and sodium nitrate. So we have to find out the weight of silver nitrate. Let the mass of silver nitrate is x. So according to law of conservation of mass, the total mass of reactants is equal to total mass of products. So that is x plus 5.85 gram is equal to 14.35 gram plus 8.5 gram. So from here x is equal to 22.85 gram minus 5.85 gram, that is equal to 17 gram. Thus the required mass of silver nitrate is 17 gram. Try to solve the numerical which I have given below and post your answer in the comment section. So let's move to second law, that is law of constant composition or law of definite proportions. It was given by a French chemist Joseph Proust in 1799. It states that a pure chemical compound always contains same elements combined together in the same definite proportion by weight. For example, pure water, whose formula is H2O, obtained from any country or any area, will always made up of hydrogen and oxygen combined together in 1:8 ratio by weight. So here in the molecule of water, the weight of hydrogen is 2 gram and weight of oxygen is 16 gram. That is, the ratio comes out to be 2:16. So the simple whole number ratio is 1:8 ratio by weight. That means pure water obtained from any area will always be made up of hydrogen and oxygen combined in a definite proportion, that is 1:8. ratio by weight. Let's take another example. Carbon dioxide can be obtained by a number of methods, such as by burning of coal or candle, by heating limestone, by heating sodium bicarbonate, etc. That is, by different methods we obtain carbon dioxide. It has been observed that each sample of carbon dioxide contains carbon and oxygen elements in the ratio of 3:8 ratio by weight. So in the molecule of carbon dioxide, the weight of carbon is 12 gram and the weight of oxygen is 16 into 2, that is 32 gram. So the ratio comes out to be 12:32, or the simple ratio is 3:8 ratio by weight. Let's see one numerical problem. 2.16 gram of copper metal when treated with nitric acid followed by ignition of the nitrate gave 2.70 gram of copper oxide. In another experiment, 1.15 gram of copper oxide upon reduction with hydrogen gave 0.92 gram of copper. Show that the above data illustrates the law of definite proportion. So in this numerical, we have to find out the percentage of copper and oxygen in copper oxide in both the experiments. And if the percentage of copper and oxygen comes out to be same in both the experiments, our law is valid. So in first experiment, 2.70 gram of copper oxide is produced by 2.16 gram of copper. So 1 gram of copper oxide is produced by how much copper? 2.16 divided by 2.70, that comes out to be 0.8. Thus the percentage of copper in copper oxide in first experiment is 80%, and the percentage of oxygen in copper oxide is 100 minus 80, that is equal to 20%. So in another experiment, 1.15 gram of copper oxide on reduction with hydrogen gives 0.92 gram of copper. So 1 gram of copper oxide on reduction gives how much copper? 0.92 divided by 1.15, that comes out to be 0.8. So here also the percentage of copper in copper oxide is 80% and percentage of oxygen is 20%. So this shows that the above data illustrates law of definite proportion or constant composition, because in both the experiments the percentage of copper and oxygen comes out to be same. This law has some limitations, so let's discuss the limitations of law of constant composition. So first is, the law is not applicable when different isotopes of same element are involved in compound formation. For example, in carbon dioxide, when carbon 12 isotope is present, then the ratio between carbon and oxygen is 12:32. But if carbon 14 isotope is present, then it becomes 14:32. Thus, in carbon dioxide, different isotopes of same element give different mass ratios between combining atoms. As in carbon dioxide formed by carbon 12 isotope, here the atomic weight of carbon is 12 gram and of oxygen is 32 gram. So the ratio comes to be 12:32. So in other case, in carbon dioxide formed by C14 isotope, here the atomic weight of carbon is 14 gram because of C14 isotope, and the molecular weight of oxygen is 32 gram and the ratio comes out to be 14:32. So in both the cases, the compound is same, that is carbon dioxide, but the ratios comes out to be different. So this is against the law of constant composition. Second limitation is when isomerism is present in compounds, this law does not holds good. For example, ethyl alcohol and methoxymethane, both having molecular formula C2H6O, known as isomers. The ratio of carbon, hydrogen and oxygen is 24 is to 6 is to 16, or in simple ratio it is 12 is to 3 is to 8 by weight. Thus, in this example, two different compounds have elements in the same ratio by weight, which is also against the law of constant composition. So here C2H5OH and CH3OCH3 both have same ratio by weight, that is 12 is to 3 is to 8. Let's discuss third law, that is law of multiple proportions. This law is proposed by Dalton in 1803. It states that when two elements combine to form two or more than two compounds, the weight of one of the element which combines with the fixed weight of other bears a simple whole number ratio. For example, hydrogen combines with oxygen to form two compounds, namely water, that is H2O, and hydrogen peroxide, that is H2O2. So, to illustrate this law, first we have to write down the compounds, and then we have to write the number of parts by weight of the elements which combine to form molecules. So here the number of parts by weight of hydrogen, and second we have to write the number of parts by weight of oxygen. So after that, fix the weight of one of the element. Let's suppose in this example we fix the weight of hydrogen to 2 parts, and last we have to find out the number of parts by weight of oxygen or the other element combining with the fixed part, that is 2 parts by weight of hydrogen. So in this example, our first compound is water. So in water, the number of parts by weight of hydrogen is 2 and number of parts by weight of oxygen is 16, because in water there is one oxygen atom and two hydrogen atoms. So let's fix the weight of hydrogen to 2 parts. So then number of parts by weight of oxygen combining with the 2 parts by weight of hydrogen is, that comes out to be same, that is 16. So in our second compound, that is hydrogen peroxide, number of parts by weight of hydrogen is 2 because it has 2 atoms of hydrogen. Number of parts by weight of oxygen is 32, and the number of parts by weight of oxygen combining with 2 parts by weight of hydrogen is 32. Therefore, the masses of oxygen, that is 16 part and 32 parts, which combines with the fixed mass of hydrogen, that is 2 parts, bear a simple whole number ratio, that is 16 is to 32 or 1 is to 2. Let's do one numerical problem related to law of multiple proportion. Copper gives two oxides. On heating 1 gram of each in hydrogen gas, 0.888 gram and 0.799 gram of the metal are produced. Show that the result agree with the law of multiple proportion. So in this numerical, the weight of both the copper oxides is given, that is 1 gram, and it is also given that in 1 gram the weight of metal, that is copper, is also given. So first we have to find out the weight of oxygen in the given copper oxides, and then we have to fix the weight of one of the element, either of metal or of oxygen, and find out the weight of other element which combines with the fixed weight of one element. So let's solve this numerical. In copper 1 oxide, 1 gram of copper oxide contain metal, that is given 0.888 gram. Thus 1 gram of copper oxide contain oxygen. We have to subtract the weight of metal from 1, that comes out to be 0.112 gram. So in copper 2 oxide, 1 gram of copper oxide contain metal, that is given 0.799 gram, and in this 1 gram of copper oxide, oxygen comes out to be 0.201 gram. Now fix the weight of one of the element. Let here we fix the weight of oxygen to 1 gram. Thus in copper 1 oxide, 0.112 gram of oxygen combines with 0.888 gram of copper. Then how much copper will combine with 1 gram of oxygen? That comes out to be 0.888 divided by 0.112. That comes out to be 8 gram. So in copper 2 oxide, 0.201 gram of oxygen combines with 0.799 gram of copper, and in the same way 1 gram of oxygen combines with 0.799 divided by 0.201, that comes out to be 4 gram. Thus the weight of copper which combines with the fixed weight of oxygen, that is 1 gram of oxygen, bears a simple whole number ratio, that is 8:4 or 2:1. So here I have given one numerical problem to solve by yourself. So try to solve this numerical and post the answer in the comment section. So let's understand the fourth law, that is law of reciprocal proportion. This law was put forward by Richter in 1792. It states that when two different elements combine separately with a fixed mass of a third element, the ratio in which they do so will be same or some simple multiple of ratio in which they combine with each other. For example, let's suppose we take three elements: carbon, hydrogen and oxygen. So first, carbon combines with hydrogen to form methane, in which carbon and hydrogen are in ratio 12:4 by weight. Now if oxygen combines with hydrogen and form water molecule, in which hydrogen and oxygen combines in ratio 2:16 by weight, then carbon and oxygen combine with each other to form carbon dioxide molecule, in which the ratio of carbon and oxygen is 12:32 by weight. So in Methane, 12 parts by weight of carbon, combines with 4 parts by weight of hydrogen. Because in methane molecule, 4 hydrogen atoms are there. So in water molecule, 16 parts by weight of oxygen combines with 2 parts by weight of hydrogen. Now, out of these 3 elements, we have to fix the weight of one of the element. So here we choose hydrogen, whose weight has to be fixed to 4 parts. Thus, the weight of carbon and oxygen, which combines with the fixed weight of hydrogen, say 4 parts by weight, are 12:32 or 3:8. Now, if carbon and oxygen combines with each other and carbon dioxide is formed, then carbon and oxygen combine directly in ratio 12:32 or 3:8 ratio by weight. The two ratios in first and second equation are same as stated by law of reciprocal proportion. Let's try to solve one numerical problem related to law of reciprocal proportion. Carbon dioxide contains 27.27% of carbon. Carbon disulfide contains 15.79% of carbon. And sulfur dioxide contains 50% of sulfur. Are these figures in agreement with the law of reciprocal proportion? So in this numerical problem, the 3 elements are sulfur, carbon and oxygen. Sulfur combines with carbon to form carbon disulfide. Oxygen also combines with carbon and form carbon dioxide molecule. And when sulfur and oxygen combine with each other, they form SO2, that is sulfur dioxide molecule. In carbon disulfide molecule, the percentage of carbon is given, that is 15.79%. So we can easily find out the percentage of sulfur by subtracting the percentage of carbon from 100, that comes out to be 84.21%. So in carbon dioxide, the percentage of carbon is given, which is 27.27%, and we can easily find out the percentage of oxygen by subtracting the percentage of carbon from 100, that comes out to be 72.73%. And third, in sulfur dioxide, sulfur is 50% and the other 50% is oxygen. So in CS2, 15.79 parts by weight of carbon combines with 84.21 parts by weight of sulfur. So suppose out of these 3 elements, here we fix the weight of carbon to 1 part. So how much weight of sulfur combines with 1 part by weight of carbon? That comes out to be 84.21 divided by 15.79, which comes out to be 5.33. In carbon dioxide, 27.27 parts by weight of carbon combines with 72.73 parts by weight of oxygen. So how much oxygen combines with 1 part by weight of carbon? That comes out to be 2.67. Thus, the weight of sulfur and oxygen, which combines with the fixed weight of carbon, say 1 part by weight, are in ratio 5.33 is to 2.67 or 2:1. Let it be equation number 1. Now in sulfur dioxide, sulfur and oxygen combine directly in ratio 50:50, that is 1:1 ratio by weight. let it be second ratio. The two ratios, first and second, are 2:1, which is simple whole number ratio as stated by law of reciprocal proportion. So here comes the last law, that is Gay-Lussac's law of combining volumes. It was given by Gay-Lussac in 1808. It states that under similar conditions of temperature and pressure, whenever gases react together, the volume of reacting gases as well as products, if they are gases, bear a simple whole number ratio. For example, one volume of hydrogen reacts with one volume of chlorine to give two volumes of hydrogen chloride gas. So in this, the volume ratio of hydrogen, chlorine and HCl comes out to be 1:1:2. That means it bear a simple whole number ratio. Similarly, in the formation of water, two volumes of hydrogen combines with one volume of oxygen to give two volumes of water vapors. So here the volume ratios of hydrogen, oxygen and water molecule comes out to be 2:1:2. That is also a simple whole number ratio. I hope you will understand the laws of chemical combination with the help of this video. If you like my video, please subscribe my channel and click the bell icon for further updates. Thanks for watching.